Let's start. Just a couple of questions to warm all of you up. For just to remind you what I taught you last term, the end of last term. So let's start off with solving the first one. 2 sine x minus square root of 3 equals to 0. And you're given that the domain is minus 360 degrees to 360 degrees. So you know what we need to do is rearrange that, correct? So by rearranging, we know that sine 2 sine x is equal to square root of 3. And therefore sine x is equal to square root of 3 over 2. Now, what I would do is, I would actually sketch out my my unit circle CAST, knowing that the reference angle x would be 60 degrees. Correct?
Yes.
Now, we know that sine x is positive. So it's this quadrant and this quadrant. And because the reference angle is 60, you know you need to draw another 60 degrees here. So therefore, we're going to work from x equals to minus 360 degrees. Minus 360 degrees, we go on this direction, correct? So therefore, it's minus 360 plus 60, which is minus 300 degrees. And then minus 240 degrees. And then 60 degrees and 130 degrees. This is how you solve it. Think about how to rearrange the equation and how to find the quadrants. Alright? So the next one, slightly different. The next one, I have given you cos 3x. Therefore, we need to change the domain. Changing the domain, which means we've got to multiply everything by 3. Alright? We've got 2 cos 3x equals to square root of 3. Without rearranging it yet, I'm going to rewrite the domain. So now it will be 3 pi over 2, and that's 3x, and 3 pi over 2. So 3x is between minus 3 pi over 2 and 3 pi over 2. Alright? So now rearranging the equation. Rearranging, you know cos 3x is therefore square root of, or actually I wanted it to be minus, but that's okay, square root of 3 over 2. So drawing your unit circle again, we know that it has to be this quadrant and this quadrant, correct? Yeah? And you know that the reference angle would be pi over 2. Am I right? Yeah? So the reference angle is pi over 2, and you also know that it has to be here, pi over 2. So it's between minus 3 pi over 2 and minus 3 pi over 2 and 3 pi over 2. So let's start off with negative. So negative, we are going to go from this minus 3 pi over 2. It's not pi over, it's pi over, sorry, it's pi over 3. Pi over 6. My fault. It's pi over 6. Right? So it's pi over 6. So you need to fit into 3x will then be, so you know that this is 1 from minus 3 pi over 2. Minus 3 pi over 2 is from here. From here, this point, all the way, that's negative. If you go up, that's negative, and that's positive, right? So we now know that this is the angle and that's the angle, that's it. So there are only 3x, which is minus pi over 6, and pi over 6, that's 3x, right? So therefore, x equals to minus pi over 18 and pi over 18. That's it. All right, you know that when we change the domain, that has to fit in there. It has to be within the x has to be within the domain once you solve it. Any question? All right. Now, from here, what we're going to do today is to think about solving trigonometric equation using various other techniques. All right. There are other things that we could do and other things that we need. So let me switch that on. So what we're going to do is think about using things like Pythagorean trigonometric identity and use other techniques. For example, quadratic to solve trigonometric equation. Couple of things that I don't have time to do for the test is actually the angle sum. So we are not going to look at the angle sum until, for you, I'm going to do the angle sum on Monday, because what I'm going to do today is solving with various technique, and then tomorrow doing some modeling question. Thursday I will give you a worksheet, a revision worksheet. I don't see you on Friday. Then Monday I'll do the angle sum, but it will not be in the test. Tuesday another revision. All right? Yeah, just to make sure that everyone is all the class are on time.
That's really hard, guys. That's good. I didn't get 100% on the test because I couldn't count apparently. Yeah. So I couldn't count. I didn't get it back yet. He still hasn't marked it. I mean, maybe he's marked it, but he didn't put it up.
It wasn't as bad as me. Those fake practice tests I did 9 plus 4 equals 11. All these stupid things to
All right. So the three things that you need to look at: the Pythagorean trigonometry identity, angle sum difference identities, which, like I say, it will not be in the test, although I will teach it on Monday, and then the null factor law. All right? So this bit, let's ignore it for a while until after the test. So the strategies for solving trigonometric functions, you need to think about factorizing. Go back to factorizing again, and the null factor law. Using the trigonometric identities, such as Pythagorean, substitute in terms of 1. Ratio, substitution for 10. Complementary and supplementary, the angle sum and difference. Angle sum and difference is basically being able to apply this formula. All right? Let's not worry about it until next week. All right? You need to know all the fundamentals of the trigonometric functions. Sine of minus theta equals to minus sine theta. Cos of minus theta equals to cos theta. Tan of minus theta equals to minus tan theta. All right? And then what are the complementary and supplementary angles, as well as the Pythagorean trigonometric function. So let's start off with next slide, which is talking about how do we look at in terms of highest common factor and null factor law. All right? Let's think about what is common here. In this trigonometric equation, sine 2x. So if sine 2x is basically the highest common factor, what do? Factor it out? All right. Now, once you factor it out, what you have is sine 2x is cos into cos x minus 1 over square root of 2, correct? Equals to 0? Yeah? Do you agree? From there, what you would have is sine 2x equals to 0, or cos x equals to 1 over square root of 2. Now here, you need to know that you have to change the domain. because sine 2x is equal to 0. Therefore, 2x, changing the domain, minus 360 degrees, 2x, 360 degrees. You must remember that. You're going to solve it for 2x and x. Yeah? So change the domain, this bit, this domain here belongs to this one. Whereas that, you apply that to this part of it. So sine 2x equal to 0. What would 2x be? So if I draw my unit circle, I therefore know that it should be here and here. Correct? Yes. Although we know that is CAST. Sine x equals to 0. Sine x equals to 0 is along the x-axis. Am I right? Yeah? Yeah? So therefore, 2x equals to minus 360 degrees, minus 180 degrees, 0 degrees, 180 degrees, and 360 degrees. So therefore, x equals to minus 180, minus 90 degrees, 0 degrees, 90 degrees, 180 degrees. All right, let's solve for the next one. Cos x. You know that will be 45 degrees. 45 degrees. All right, so these two are 45 degrees. You know it's between minus 180 to 180 degrees, which is from here to here. So it's minus 45 degrees and 45 degrees. That's all. So x equals to minus 45 degrees and 45 degrees. So putting everything together, x therefore equals to plus or minus 180 degrees, plus or minus 90 degrees, 0 degrees, and plus or minus 45 degrees. All right? Pretty straightforward. All you need to know is if you could factorize it. Highest common factor factorization, factor the sine 2x out, and then use your now factor law. Any question from there? And remember, you need to change your domain because you're solving for 2x. In this case, now factor law. The first one is sine 2x equals to 0, and then cos x equals to 1 over square root of 2. All right? Yes?
In a test, could we write x as equal to like the plus and the minus, or would we have to write each?
Nah, that's fine. Plus or minus is fine. I'm happy with that. They're both correct. So the next one, you could use two ways of doing it. Either the phase shift or angle sum and difference. So like I say, let's not worry about that yet. Let's do the phase shift. Phase shift, looking at that, you would know that we need to change the domain. The domain is now x plus pi over 3. So I've got to change the domain to 0 plus pi over 3, which is pi over 3, and x plus pi over 3, and then 7 pi over 3. All right? Now, you must always write this one out when there's a change in domain for the exam or the test. That's always worth a mark. All right? Remember that. That's always worth a mark. Always, when you look at something like this, make sure that you recognize that there's a domain change. So with the domain change, now we know that we can cos x plus pi over 3 equals to minus square root of 3 over 2. Let's draw our unit circle. Now this is a technique that I like to use. I always like to draw my quadrants and my unit circle knowing where they are. All right? It may not be what you like, it's up to you. I like to do it that way so that it is clear for me. So drawing that, I know that I need 5 pi over 6 and 7 pi over 6. So let's see, that is cos negative. This is this part, and this is this. All right. So what is the reference angle? What is the reference angle? What's the reference angle? Pi over 6. So what I do is, when I know that, if I know the reference angle, that's my way of doing it. When I know the reference angle is included, I do a solid line. When I know that the reference angle is not included, I do a dotted line. It's just to remind myself, my technique of answering the question. All right, it's up to you whether you want to make it clear to yourself. Okay, understand that? So that's what I do. If it is not included, my technique is I use a dotted line. So it's pi over 6. So we know that we need here pi over 6 and pi over 6. Then you know that x plus pi over 3 equals to 5 pi over 6 and 7 pi over 6. So therefore, x equals to 5 pi over 6 minus pi over 3, or 7 pi over 6 minus pi over 3. And that is pi over 2 and 5 pi over 6. All right? That's how I do it. That's x. But this, like I say, all the way I do it, I'll always like to have my quadrants or my unit circle so that I know there's a circle in there, so I didn't bother drawing it. And I know dotted line, I don't include that angle. That's just my reference angle. Those are the two that I need. I know solid line, I know that the angle, the reference angle is included. All right? Any question before I move on? Next one. All right. Quadratic factorization. How do you factorize this? Sorry? Now, what I'm going to suggest is, before you do anything, you can let sine x equals to, let's say, b. All right? So therefore, you make life easier for yourself by writing it out as b squared minus 3 over 2b plus half equals to 0. All right? Let's do it that way. Just substituting sine x as b. So you got b squared minus 3 over 2b plus half. And therefore, you know that 2b squared minus 3b plus 1 equals to 0. So can you therefore factorize that? Of course you can. Let's do a grouping. So is 2b squared minus 2b plus b minus b, sorry. Minus b plus 1 equals to 0. Therefore it's 2b, b minus 1. Minus b minus 1 equals to 0, 2b minus 1, and b minus 1 equals to 0. All right? Now substitute your sine x back. So 2 sine x minus 1, sine x minus 1 equals to 0. Therefore, sine x equals to half or 1. Correct? Makes life a little bit easier for yourself by substituting sine x as b once you have the square. All right? So with that, you can therefore solve x. You don't have to change the domain at all. So x is therefore pi over 6, 5 pi over 6, or pi over 2. So once you have a quadratic equation, factorize it. All right? Next one, tangent ratio. Why did I say tangent ratio? What is tangent x? Sine over cos. All right? So therefore, dividing both sides by cos x. So sine x over cos x equals to square root of 3. tan x equals to square root of 3. So therefore, you know it's between minus pi and pi. I should have drawn my unit circle. So I know it has to be here and here. So drawing my unit circle, CAST, you know it's here and here. So, and therefore x equals to minus 2 pi over 3, pi over 3. Alright? Pi over 3 is included. Pi over 3. Alright? One last example. How do you solve this? Pythagorean identity. What is sine square x?
1 minus cos squared of x.
That's right. So because you know sine square x plus cos square x equals to 1. So therefore, you've got 1 minus cos square x plus cos x equals to 1. And rearranging it, cos square x minus cos x equals to 0. So cos x up. What am I doing? Cos x minus 1 equals to 0. Cos x equals to 0 or cos x equals to 1. Now you can solve that again. You know that CAST is this point here, correct? Yeah? Cos x equals to 0 or cos x equals to 1.
So,
Sorry?
isn't the second line going to be cos squared plus cos squared?
Sorry?
Second line.
Cos square minus cos x, because that's 1 minus cos x. Alright? 1 take away 1 is 0. And rearranging, moving it everything to the other side. Alright? Got it? Yeah? So therefore, x equals to plus or minus 2 pi, plus or minus 3 pi over 2, plus or minus pi over 2, and 0. Alright, that's all you need to do. So you need to be able to use all you have learned, all the technique I've shown you, to actually solve the trigonometry equation. Alright, I'm going to stop here. You've got half an hour to practice some of these questions. So I have set all the questions including angle, sum and difference identity. If you see a question like this, just ignore it for a while. Although I'll teach you on Monday, you can work on it after the test. Alright, I'm going to stop here.
Zero.